Alright, so this is just a general idea of what are we going to do with balancing. Remember, balancing, we have to talk about what goes in must come out. Okay, so if we have a chemical reaction like the basic chemical reaction of H2 plus O2 giving us H2O. Right. Now, you can see that there are not an equal amount of H's and O's on both sides. So, if we pretend that H2 is now a molecule such as that, then we can pretend that oxygen is a molecule such as that. And when we draw the molecule of H2O, it would look something like that. Okay, so what you can already see is that the H's are equal on both sides of the arrow, but the O's are not. This is where where it is required to do some balancing. Okay, so we know that there's two of them, so therefore we need another one on this side. But because we can't just add on an extra O because there is no O by itself, we must add on a whole extra one of those molecules. So that means we have two there. That means our O's are balanced, but now our H's are not balanced. But this is easy enough because we have two here, now we have another two there. So all we need to do is add in another one like that to give us a balanced chemical reaction. Now, some of you are going, well, why don't we just halve that? No, we can't halve a molecule. The reason being, because you have learned that certain molecules are always going to come in pairs. Those are your diatomic molecules or diatomic elements, such as H2, well, the ones we've seen already, O2, N2, F2, Br2, I2, Cl2. Those are always going to be in pairs. Those are diatomic. Alright, okay. So another example would be something like if we looked at the creation of ammonia. Okay, N2 plus H2 gives us NH3. Now, they do not change. We've learnt the law regarding this, why it does not change. Okay, it will not be halved, it will not be doubled, it will not be doing anything because of the law of constant composition. Now, at the end of the day, what I want you to do is actually do this without using any sort of aids or without any working out. This is what I would expect you to do at the end of the year or next year in grade 11 and grade 12 even quicker. But for now I'm going to show you a few methods that we can use. Okay, so in this one, let's just say there are two here, and now there's 1 and 3. Okay, do you see that in order to get these two equal, it's going to be a bit more of a mission. So what we can do now, we can say we just start somewhere. 2 and 3 don't go in together, so let's not start there. 2 and 1, we can multiply this one by 2. If we multiply this column by 2, we must multiply everything in it by 2. So that means this is 2, this is equal, right? But now this is not equal. How do we get this 2 times 3 to be equal here? Well, all we need to do is multiply this by 3. So, at the end of the day, we can just put the 2 there and the 3 there. So we rewrite it into plus 3H2 gives us 2NH3. Okay, now let's have a look at an example from your book. Okay, we'll start from the beginning. 2.1. Okay. What I'm going to do is I'm going to give you this video, and then I'll give you until 12 o'clock to finish the work again. Okay, so that means you can use the methodology that is involved to find the balanced equation. Alright, so this one is a bit more complicated because there's three different elements. So there's carbon, there's hydrogen, and there's oxygen. What we can say is that there are 2 carbons and 2 hydrogens and 2 oxygens. Okay, and over here we've got 1 carbon, 2 oxygens, but 2 hydrogens and another 1 oxygen. Do you see what I've essentially created here is that I'll split them into the different elements and the amount of each. Okay, now what we can see is that the carbons do not add up, hydrogens do add up, oxygens do not add up. So again, we just need to start somewhere. It doesn't matter where we start. It doesn't matter if we start on the oxygens or the carbons or the hydrogens, it doesn't matter. Just start somewhere. You have to make mistakes with these questions. You have to just trial and error balancing. Alright, I'll be able to do them more efficiently than you are, obviously, because I've had a lot more years of practice. But the idea is that just start somewhere. Okay, so even if you wanted to go and say, well, 2 plus 1 is 3, doesn't go into 2, so we can make that more equal to 2 by multiplying certain things by 2 or 3 or whatever. But maybe you go and say carbon looks like 1, which is easy enough to do, because all we need to do for carbon is multiply this by 2. Remember, in the column we multiply everything by 2. So that means we get 2 carbons and now we have 4 oxygens. Alright, but now the problem is 2 times 2 is 4 plus 1 is not, 2 cannot go into that. 2 cannot go into 5. So we need to get this 1 to be an even number. So we multiply it by 2 as well. But we times everything by 2. Oh, but then if we times this by 2, then we have to times this hydrogen by 2, which means we multiply this by 2. And then, oh no, we have to multiply this by 4, which again works down to work that by 4. But by this time you're going, fine, we've gone from this to this, to this, to this, to this, back to this. Okay? And then from that, now we can see that 4 times 2 is 8, plus 2 is 10. Can 2 go into 10? Yes, 2 can go into 10 if we multiply it by 5. Okay, so yes, trial and error, trial and error, trial and error. So now we rewrite it. 2C2H2 plus 5O2 gives us 4CO2 plus 2H2O. Okay, so that is a methodology that you can try for the rest of those examples that I've assigned you.